Recursive partition cosmology and the near-extremal Kerr universe. A consolidated falsification digest for peer review. Chris D. Seely, with Brad Yoakum. Draft prepared for ResearchGate peer review, consolidates and cross-references two independent preprints. Abstract. This document consolidates two related but independently constructed frameworks, the near-extremal Kerr universe model and recursive partition cosmology, into a single falsification-oriented reference for peer review. Both frameworks propose mechanisms addressing the cosmological constant problem and galaxy rotation curves without invoking dark energy or dark matter as free parameters. The two frameworks use distinct and not yet reconciled mechanisms. This is stated explicitly rather than merged into a single narrative, following the practice already established in the source documents. Every claim below is tagged by evidentiary status, derived, motivated, confirmed, outstanding, or excluded, so that a reviewer can identify immediately which statements follow from stated axioms, which are structurally proposed but undemonstrated, which have been checked against public data, and which have failed numerical checks and been withdrawn from the framework. The purpose of this document is to state predictions and their test conditions plainly, in the sense intended by Popper's falsifiability criterion. A scientific claim is one for which an observation or calculation that would contradict it can be specified in advance. No comparison to, or claim about, any other researcher's position is made in this document. The frameworks are presented on their own terms and against public data alone. 1. Purpose and scope. This digest does two things. First, it summarizes the axiomatic starting points of each framework so a reviewer can check whether later claims actually follow from them. Second, it separates every substantive claim into one of 5 categories. Derived follows from the stated axioms with no additional assumption. Confirmed checked against a public dataset with a stated, pre-specified test. Motivated has the correct structural form for the intended role but has not been derived from more primitive terms, treated as a working hypothesis, not a result. Outstanding, an explicitly identified gap in the derivation chain, listed with the specific mathematical or physical problem that remains open. Excluded, a claim that was checked numerically or dimensionally and failed, retained in the record so it is not silently reintroduced or independently rediscovered by a reviewer. This taxonomy is not new to this digest, it is carried over directly from the source RPC preprint, which already applies it internally. The main editorial change here is to apply it consistently across both source papers and to remove language that asserted the frameworks had defeated, refuted, or rendered unnecessary the positions of any named researcher or research program. That language is not part of a falsification argument in the Popperian sense. A falsification argument specifies a test of a specific quantitative prediction, not a categorical judgment about a rival's framework as a whole, and has been removed. 2. Axiomatic foundations. 2.1 Unity Division Arithmetic, Near-Extremal Kerr Universe paper. The near-extremal Kerr framework is built on 7 axioms constructing arithmetic from a single primitive, 1, using only division, with 0 and infinity explicitly disallowed as numbers, operators, or limits. Gaps generated by admissible divisions must close by further division except for a class of gaps that persist as stable, double-covered structures requiring 2 full turns for identity return. The physical claim of the paper is that the void and the black hole event horizon are the 2 stable holes of this arithmetic system, and that the residual 12-order gap in the cosmological constant anomaly is the Pythagorean comma, the closure failure of 12 successive 3/2 divisions against 7 octave doublings, 12 halves 7 approximately equals 1.01364. 2.2 Recursive partition cosmology, 6 primitive constraints. RPC begins from a single normalized conserved substrate U equals 1 with 6 constraints. Exact global conservation under partition. Recursive division as the only primitive operation. No pre-existing geometry, metric, or coordinates. No infinitesimals, entropy as a count of distinguishable partition states, and the requirement that stable structure arise only where recursive packing fails. Both frameworks therefore share a common structural commitment: no infinities, no zero, infinitesimal limits, and irreducible closure failure as the generator of physical structure, despite using different formal machinery. 3. The cosmological constant problem: two independent candidate mechanisms. Both frameworks address the same anomaly, the roughly 123 order of magnitude discrepancy between the Planck scale quantum field theory estimate of vacuum energy density and the observed dark energy density, but propose mechanistically distinct resolutions. They are presented separately below. A reviewer should not read one as confirming the other. At present, they are two candidate explanations of the same number, not two derivations of the same mechanism. 3.1 Mechanism A, near-extremal Kerr horizon suppression. Identifying the observable universe with a near-extremal Kerr black hole drives much less than the horizon's Hawking temperature toward zero. This removes 111 of the 123 discrepant orders as a consequence of the extremal limit thermodynamics. The remaining 12 orders are proposed to correspond to the Pythagorean comma, treated as a theorem of the Uda axioms rather than a further free parameter, via a 12-level harmonic hierarchy of physical energy scales from the Planck density to the observed lambda, each level separated by roughly 10 to the power of 10. Status. Motivated. The partition of 123 into 111 plus 12 is presented as exact, but the derivation that epsilon must equal approximately 10 squared from the Uda axioms alone, independent of fitting to the observed lambda, is not carried out in the source paper. The harmonic level assignment in Table 1 associates named physical processes with each level post hoc rather than deriving the association forward from the axioms. 3.2 Mechanism B RPC holographic pi-squared screening. RPC proposes rho lambda tilde rho Planck times squared, i.e., that the vacuum energy density scales as the square of the ratio between the Planck length and the Hubble radius. Numerically, this gives rho lambda approximately equals 7.1 times 10 squared to the power of 6 kg per cubic meter against an observed value of 5.96 times 10 squared to the power of 7 kg per cubic meter, within a factor of 12. Status. Motivated, explicitly labeled as a qualitative rather than exact resolution in the source document. The residual factor of 12 is stated as requiring derivation from a full condensate equation of state that has not yet been carried out. 3.3 Relationship between the two mechanisms. Both mechanisms converge on a residual factor near 12 and both invoke the same term, Pythagorean comma, but they arrive at it through different routes. Mechanism A treats the residual as the exact closure failure of a specific harmonic construction applied to a proposed 12-level energy scale hierarchy. Mechanism B treats it as an unresolved order of magnitude gap in a holographic scaling relation, with no claim that the number 12 is itself derived rather than observed post hoc. These are not the same derivation restated in different notation, and this document does not present them as such. Reconciling them, or determining that only one is physically correct, is not currently done in either source paper and should be treated as an open problem, not as mutual confirmation. Any reviewer encountering both papers together should expect to be asked which mechanism, if either, is intended as primary. At present, the honest answer is that this has not been decided. 4. Falsification criteria, consolidated table. The following criteria are drawn directly from the falsification sections of both source papers. Each specifies a prediction, a test method, whether the required data currently exists, and the stated condition under which the claim would be considered falsified. Each specifies a prediction, a test. Prediction 3 of the Kerr paper and Prediction 4 are longer horizon instrumental tests rather than tests against existing public data, and are listed separately in Section 6. 5. Confirmed empirical result. 5.1 Spark rotation ceiling. Status. confirmed against public data. Applied to the full spark sample of 175 disk galaxies. The two-phase model predicts a hard rotation velocity ceiling near 300 km per second for galaxies coupled to the cosmic Webb phase, set by the alpha speed at observed intergalactic magnetic field strengths and densities, with zero free parameters. 174 of 175 spark galaxies fall at or below 298 km per second. The single exception, UGC12591, V flat equals 313 plus or minus 8 km per second, is an isolated void galaxy with an unusually large baryon deficit, consistent with the model's separate prediction for void decoupled galaxies. Sequence, as stated by the author. The ceiling value and the separate void decoupling criterion were both derived from the alpha speed, Landau critical velocity physics of section 6.3 independently of, and prior to, any examination of the spark catalog or its distribution of rotation velocities. Neither author had prior domain knowledge of the spark sample, UGC 12591, or galaxy rotation curve astronomy generally before this calculation was performed. The spark data were consulted only afterward, to check the zero free parameter prediction against a public dataset. This is the a priori sequence. Popperian falsification requires a prediction stated in advance of, not fitted to, the confirming or falsifying observation. Note for reviewers: this sequence is the author's account of the derivation history and is not independently timestamped in the source preprint. If a dated record exists, a notebook entry, an earlier preprint version, or a version-controlled draft showing the ceiling value computed before the spark comparison, citing it would materially strengthen this claim for referees. Since we predicted this before checking, is an assertion a rigorous reviewer will otherwise ask to see substantiated. 5.2 Hoag's object. Status: motivated, consistent with, not independently confirming. Hoag's object is presented as an observational anchor for the void limit gyroscopic ground state. An isolated ring galaxy with a flat rotation velocity of 270 to 300 km per second, near the spark-derived ceiling, in a void with no known neighbor within 3 MPC. This is a single case consistent with the framework's predictions. It is not, by itself, a statistical test, and is not presented as one in the source paper. 5.3 The 15 MPC Meerkat, Daisy filament. Status: motivated, with predictions testable but not yet confirmed. The 2025 Meerkat, Daisy, Mighty survey reported a 15 MPC filament with bulk rotation of 110 km per second and opposite sides moving in opposite directions, a dual counter-rotating structure. Applying the two-phase partition, superfluid framework already in place, this measured counter-rotation is identified as the direct kinematic signature of second sound in a two-component superfluid, without introducing new free parameters. The measured 110 km per second is used as the local second sound speed C2. Local, and 4 further quantities, a filament galaxy rotation ceiling, a BTFR offset, a break radius shift, and a spin phase lag rate, are computed from it using the same relations already established for the galaxy scale case. Sequence, as stated by the author. As with the spark case, the identification of dual counter rotation as a second sound signature, and the 4 quantitative predictions derived from it, were arrived at from the framework's existing zero free parameter relations before the author was aware of the specific published Meerkat, Daisy, Mighty high measurement being available to check against. The published survey result was located afterward, as the confirming or falsifying dataset for a prediction already implicit in the framework's structure, rather than being the starting point that the 4 predictions were fitted to. The author reports no prior background in this specific area of radio astronomy. This should be read with the same caveat as section 5.1. The sequence is asserted, not independently timestamped, and a dated record would strengthen it. What has and has not been confirmed here should not be conflated. The qualitative identification and the Landau stability check are consistent with the single published measurement. The 4 specific numerical predictions require the resolved rotation curves of the 14 galaxy high sample and follow-up optical spectroscopy that, per the source document, have not yet been carried out. Until that follow-up is done, this result stands as a well-specified, zero-free parameter, a priori set of predictions awaiting test, not as a second confirmed result alongside Spark. 6. Longer horizon instrumental predictions. 3 predictions require instrumentation beyond currently available public survey data. Delta G, G approximately 10 squared between void and cluster environments, proposed test via the QLAG atom interferometric sensor architecture, stated sensitivity due approximately equals 1.01 times 10 cubed radian per second, square root HC. Cosmic spin axis alignment across CMB quadrupole, octopole and galaxy angular momentum statistics at sub-degree precision, full test requires Euclid cross-correlated with Planck PR4 data. Population statistics of near-extremal spin parameters among massive black holes, accessible within the LISA mission lifetime. Because these depend on instruments that are either proposed by the same authors or not yet delivering data, they should be read by reviewers as motivating a future observational program rather than as currently testable claims. 7. Excluded claims. Status: excluded, retained in the record for transparency. The claim X sphere, pi caret 1.93 equals alpha. Numerical check gives 0.0663 against the actual alpha equals 0.007297, a factor of approximately 9 discrepancy. This claim fails and is not part of the framework. A derivation of alpha from partition dynamics remains an open problem. The 0.367 approximately equals 1 minus 1, phi equals 0.382 correspondence noted for the 15 MPC filaments Landau stability ratio is explicitly flagged in the source document as a suggestive numerical parallel, not an exact derivation, with a stated 4% discrepancy. It is retained here at that same status, noted, not claimed. Signal amplitude predictions for the proposed dual torus laboratory device and for seismic precursor sensitivity depend on coupling constants that have not yet been derived. The source document states these predicted amplitudes currently fail dimensional analysis and are excluded pending that derivation. 8. Outstanding derivations. 12 specific gaps are identified in the RPC source document. They are listed here without modification, since restating them accurately is more useful to a reviewer than summarizing them away. (9) Conclusion. Both frameworks make specific, dated, quantitative predictions against public or soon-to-be public data, and both explicitly identify their own unresolved derivations rather than presenting the work as complete. The single result that has been checked against existing public data and holds the Spark rotation velocity ceiling. With 0 free parameters and 1 correctly anticipated exception, is the strongest evidentiary claim currently available and is where a reviewer's attention is best directed first. The cosmological constant mechanisms are not yet reconciled with each other and should not be read as mutually reinforcing. The excluded claims and outstanding derivations are listed in full because a framework's falsifiability rests as much on what it has ruled out and left open as on what it currently predicts correctly. End of Consolidated Digest.